So I'm going to work down through his build more carefully for the first time and do some of the things he suggests. Now, these weren't in, if you were going to Arducopter for the first time in the documentation, I don't know if they ever really point you towards these, or, I'm sitting here thinking, boy, what do you say to people if you work through that documentation? You don't really have a flyable platform, in my opinion. Boy, that's bad. So I think you do have to go through some of the advanced features in that documentation, of which you've just seen. Compass motor compensation is a big one. So I will work down through this with a fine-tooth comb, but first I'm going to go do some of the things that he talks about. And that compass motor compensation is one of the things you've heard me kind of talking about from day one. That's one of the things that's gotten me out of trouble in the past that I wanted to do, but because it wasn't straight up in the Arducopter documentation, I didn't do it. Now I'm going to do it before I fly it again, in fact. Wished I'd have done it before I flew it at all. Going to go more with my instinct in the future and not bend it backwards to the documentation, etc. So, again, it's not a how-to, it's a how I do it. So, a little bit upset with myself right now for not sticking to my guns and doing it previously. So, because of this statement right here, he found it to be problematic. He did his IMU, and he states it here as precise IMU and compass. I will put this address in the description line of the video, but I came in here and watched this video, and I like this guy a lot. He's as anal as I am. See this piece of material he has right here? He goes ahead and redoes his accelerometer calibration as part of this video. And he is so precise, which I like to be more than accurate, that he uses this piece of whatever it is to make sure he gets his verticals at 90 degrees when he does his calibration of his accelerometers again, and I love it. But I did watch this video. He does the accelerometer calibration again. He does the temperature calibration on the IMUs and fails on the barometer, but says he's going to address that in the future, which I think he did, and I will. And then he does the compass motor calibration, which I am going to do here. Now, I'll show you a little bit of what I'm working against here for things. Oh, by the way, he puts smaller props on his platform to do the compass motor, and I'm not going to. I think it really needs the props you're going to fly, because that's what's going to generate the same amperage. Putting smaller props on them, the amperage is not going to go as high, in my humble opinion. But I'm a layman. So real quick, let's run out and look at my accelerometer calibration I have already talked about redoing. Well, the kitchen counter's not level. I can't do the accelerator calibration here. Well, the dining room table isn't exactly level, but it's 90 degrees different than the kitchen counter. Well, the garage is the most level. I think I might have finally found me a level place. Now, I'm not really going to get this crazy over this. I will take it out to the garage and do it, but the garage isn't exactly level either. There's something about this whole property. I don't know, or whoever built it. I have no idea what it is. And I'm not going to get so anal that I go off this property to a grocery store, a gym, or something like that to find a perfectly level place. I suspect it's not that big of a deal if it's slightly off. Things will be copacetic. But because my bench and this whole house is so unlevel, it's going to be as much as I want and as much as I really need to do. Just go do it in the garage. And tell you the truth, I'm probably not going to worry about the 90 degrees vertical with a piece of material like he did, or I may. I got some concrete blocks out there. I can try to make that more precise, but that'll do it on this. I just want to go back over everything I can and just polish it a little bit. And no, that the garage isn't even really level here, and I'm not going to video me redoing this simple accelerometer calibration in the garage. I think you know what I'll do. And he also does his compass calibration again here. He wants to do it with the battery on it. And again, I think it's because of the materials in the battery, even without it plugged in or pulling any power, can shadow and affect the signal a little bit. Any metal around a compass. He does it indoors. I recommend it outdoors. I did mine indoors for the same reason I am suspicious that he did. It's a convenience thing to go on with other things, knowing you're going to go back later and do it outdoors to get it much better. Or he may have new tidbits I haven't viewed yet, where he gets a really, really sharp compass calibration through data flash logs or something that I haven't got through to yet in these videos. I'm just sort of polishing up the things that I wanted to do, like compass motor compensation, that I didn't get to. Now I'm going to call that compass motor calibration. I'm going to call it compass motor compensation. I'm going to call it the compass motor calibration compensation utility. Any one of those flavors, please forgive me. So I may have a little egg on my face, I'm not sure, because I went back to see how I messed this up, and in the first time setup under configuration, when you get to the compass calibration part, and it goes down through this, right here in the top, it says this article explains how to perform basic compass calibration. It assumes that you have at least one compass, either internally or externally in the system, and it has been enabled. It says see advanced compass setup for more information and to set up other compass related features. So one could interpret that as I was directed to this page. Perhaps. We'll see here. I think it should be more emphasized or expressed. Maybe I'm just too stupid not to understand I was directed there. We're going to assume I made a mistake. That's the way I work. So one would go over there and at least read it. I'm going to at least put it to that. I know what's over there. I just didn't go read it this time because I knew basically what was over there. And I felt I should have done it, but I didn't follow my instinct because I was trying to work down the documentation as it is today after years. Before 2016 did I ever read the copter docs. Compass calibration cannot be performed while the vehicle is armed. Well, thank God. Do not calibrate near any metallic or magnetic field producing objects, computers, cell phones, metal of any kind, or an incorrect calibration could occur. Usually will. And this basement was just too full of that. I just do that to get the mandatory things out of the way so I can proceed on with some things, and forgot to go back and redo it. Don't do that. Be smarter than me. Set up mandatory hardware. Got to watch these docks too. Sometimes it isn't exactly the current screens. God, how many compasses have you got on this thing? 6? Jiminy cricket. You're kidding me. He's only maybe 2. Not sure what this is. Oh well, that's not the point of our current video. Just going to skip right over that. You may wish to disable any internal compasses if you are consistently seeing the inconsistent compass pre-arm message office. Well, I've never seen that, but I've seen mag anomaly and some other messages. Onboard calibration. Calibration could fail for the onboard compasses if the autopilot board orientation parameter is not correct. Well, it should. Here's how to perform. I don't have a buzzer on mine. Maybe I should get that buzzer on there. Hold the vehicle in the air and rotate it. Most of us know how to do the compass dance. I'm getting so old and my internal components are getting so wore out. Rotating around and around makes me dizzy easily nowadays. Oh my God. If calibration fails, you'll hear an unhappy tone. I just watched my screen for when it told me it was done. Here's the onboard calibration using stick gestures. I've never done that one. I think that is a really good one to do because it lets you get outdoors with it easily without a ground control station connected, especially if the only way you can connect your ground control station is with a USB cable. Try to get away from that as quick as possible. Having an imaginary USB cable or telemetry is so useful on this. Even if you don't fly telemetry ground station, it is really useful during setup to have a imaginary USB cable instead of a physical one. Let's see. Ardu Pilot supports onboard calibration using RC control stick gestures, meaning that the calibration routine runs on the autopilot with no ground control station attached. This method is more accurate than the older off-board calibration, live calibration, which runs on the ground station because in addition to offsets, scaling is also calculated. Ooh. I heard rumors of that in the last 48 hours through some messaging, but now I see I should probably redo my compass calibration for kicks and grins with this method and have a better calibration, more precise. Just, it never hurts to polish things. Now, one little problem is I don't have a buzzer, so I'm going to have to put my buzzer on and see if it works before I can do this. But we're going to put that in the back of our head for if it fails, you'll hear a failure tone. Large vehicle mag cal. This is what I used on all my airplanes. I don't care what the hell they were. I tried to use it on the copter. It didn't work on the copter. I don't know if Ardu copter doesn't do it or I just didn't have a good GPS lock before I tried it. I might go back and investigate that one, but it didn't work for me like it did on Ardu plane for the last 2 years while building those airplanes behind me. And I just put my cell phone on top of the airplane and put a compass app up and read the degrees that the cell phone was pointing and typed that into the area of mission planner that it needs to be and hit enter. Man, you think I'm going to sit here with a Sky Hunter 1800? In truth, it's real easy to do with a Sky Hunter with just the fuselage. Wings off, tail booms and tail off. So, but I'm a semi-lazy person. Additional information. More information about compass. Man, more information about compass configuration can be found in Advanced Compass Setup. I can edit those things out of my videos and posts if everybody wants me to edit out my mispronunciations that I laugh about. Or if you do them too, you might care to see that I do it. Feel more normal. I am a human. So this goes, more information about compass configuration can be found in Advanced Compass Setup. You can read this two ways. You can read that as it's a offer to go over there, or you can read it you're being redirected again to go over there. So this instruction includes how to set up additional compasses, automatic setting of offsets, which I've never done, I want to do. Airplanes have a new way of doing automatic setting of offsets. I didn't do it the old way on any of my platforms yet. I do want to play with this. I can't find too much information about it. We'll see that in the future. Non-standard compass alignments. I had to do that, but it's fairly understandable by me just reading the parameters in Mission Planner when I got to that. And CompassMOT, that good old compass motor compensation, etc. General discussion on magnetic interference as ways to reduce it can be found in magnetic interference. Video demonstration of all of this stuff, including the compass dance here. So maybe, I guess in the future, because of my instinct and because of what I learned through my mistakes for this, I'm going to just start changing. If I ever do this again for any other vertical, I'm going to say, yeah, you need to come over here for this one simple thing. Compensation for interference from the power wires, which I think is my biggest problem. ESCs, I don't think the ESC's that close, my humble opinion. It's pretty close. I can measure it. It's 6 or 8 inches. I wish it was more. But I think the motors are far enough away. I could be wrong about the motors. I don't know how big of a magnetic field they build out. So we're kind of to the bottom of this. I'm not going to go out and read about compass interference to you or any of the other of this right now. I will hit that if I find it to be important in a separate video. We will go here, which is right here. And this part will be part of it, so I can kill that tab. The article provides advanced guidance on how to set up system compasses. Just reading through this quickly, because we did go through this basically on the original compass setup and calibration. Compass enables. See, I'm getting some bitches about that, but in my setup, something about mag not enabled, and I can go back to the data flash logs, but I think you've seen it. But I only have one compass in this creature, I think. I'm going to have to go back and look at the slim. I don't think it has a compass in it. And I did, when I was in here, these two were checked like this. But I unchecked them because the system only finds one, in my opinion. I only have one enabled out there. This, if you go into the full parameters, you'll see this is changing and enable. I figured, what the hell? Speed all the hardware and software up, because I know both so well electronically. Not having it have to even deal with whether or not it has this should speed up the software. Same hardware. You can't actually speed up the hardware by telling it not to use something, but you can tell the software to quit looking in that area by doing stuff like that. So I did it. And I'm going to leave it that way. And this I want to get into someday. I've never done that. So any one of the first three compasses can be disabled. This would leave only the remaining ones to be used by the autopilot. You may wish to disable any internal compasses if you are consistently seeing inconsistent compasses pre-arm messages often, and you're sure that the external compass is calibrated. Well, I'm seeing some strange messages, but I only have one enabled, so I'm going to go past that. This is evidently not the answer to what I'm seeing. Compass should always be enabled for copter and rover, but may be disabled, not recommended. Ardu Pilot does not recommend that you disable a compass for plane. You know, I've got that standing little fight that they should change this documentation right here if it's not true. I think perhaps Ardu Plane is the only firmware that doesn't crash when using a compass. I have not proved this one yet, but I am going to turn one of my planes, the Nano Talon that I did not build, it was built for me. I'm going to use it with a compass. If it crashes, I'm not so worried about that as the ones I did build. I'll sacrifice it to prove the point, or have my thinking changed. Either one is acceptable to me. Orientation's important. We don't need to go over that. Oh, this talks about compass orientation. In-flight calibration? No, there's no such thing as in-flight compass calibration. Oh, that's automatic offset calibration. So now we're down to it. Yeah, there's not much else here. So this is where we're at and what I'm going to do. So this is recommended for vehicles that have only an internal compass. Well, the gentleman whose build I got parts list from is doing it. And I guess this right here is what stopped me from doing it the first time, perhaps. I remember reading this. And on vehicles where there is significant interference on the compass from motor, power wires, etc. That's what I am suspicious of right now. CompassMOT only works well if you have a battery current monitor, because the magnetic interference is linear with current draw. It is technically possible to set up CompassMOT using throttle, but this is not recommended. Now then, that's why I wanted to get my current reading calibrated. Enable the current monitor, disconnect your props, flip them over, rotate them in one position, secure the copter, perhaps with tape. Really? Tape? Okay. I'm using zip ties through a piece of plywood so it doesn't skitter around horizontally. But tape? I wonder if some poor sucker ever used Scotch tape and got a surprise. Turn on your transmitter, keep throttle at 0, connect your vehicle's LiPo battery, or any battery you're going to use, I would assume. Connect your autopilot to your computer with a USB cable, or a telemetry connection if you don't want to have an extra cable in the mix while props are spinning. Yeah. See, telemetry, good, even if you don't fly a ground control station. My opinion. Open the initial setup hardware option, calibrate motor cam screen, and press the start button. Well, don't do that quite yet. You should read through the rest of this. You should hear the ESC's arming beep. Raise the throttle slowly between 50 and 75%. If you watch his video, you'll see he says to do it quickly to 75%. The props will spin for 5 to 10 seconds. Well, they'll spin forever. How long you hold that up, buddy? Quickly you bring the throttle back down. That's always been very important, that fast drop of the throttle. Press finish to complete the calibration. Check the percentage of interference displayed. If it is less than 30%, then your compass interference is acceptable. And you should see good loiter, return to launch, and auto performances. Probably affects auto tune and any non-manual flight mode. If it is 31 to 60%, then the interference is in the gray zone, where it may be okay. Some users are fine, some are not. If it is higher than 60%, you should try moving your autopilot further up and away from the sources of interference. What? Wait a minute. Shouldn't you? If it is higher than 60%, you should try moving your compass further up and away from sources of interference, or consider purchasing an external compass or GPS Plus module. Some of these, I think they did just as bad as I do frequently, and I will always forgive little mistakes like that. We're human. If it is higher than 60%, you should try moving your compass further up and away from sources. Some of my quads, I have the module up on a mast. That's frequent with a quad, and why wouldn't that work on this platform? Wow, that is a thought. It would work if I use the kind of masts I have here. It would work with doing freestyle, my normal stuff. It would break real easily if it crashes, but boy, I don't want this so much because it's crash resistant. I just want it for its performance on long range flights. I hope it's flying perfectly level, straight out and straight back is what I'm mostly after. Okay, I do want to do some flips and rolls, but I'm not even learned acro mode yet, so boy, what's a thought? I'm sitting there staring at it, looking at it, going, So that's what we'll do. And then there's the automatic offset calibration, which I've never used. I do want to learn it. I figured I would fly it one flight and try to learn it, but just haven't got to that yet. And then they talk about compass error messages and refining calibration parameters using a flight log. Oh, cool. He may get into that. MagFit Python utility. Whoa, I've never heard of that. Cool. Very cool. Yeah. We may be able to get this compass calibration. I suspected this. Maybe it's because I watched some of his video and I'm barely remembering some of the things I remembered. But anyway, let's get out there and get at it and get us a little CompassMOT. Compass motor compensation done. If nothing else, we're going to see what the interference was. By the way, in his build, let me see if I can find it. His was 85%. So I see why he said this proved very problematic. We'll see what mine is, because I've been very suspicious for a very long time. Okay, I'm going to do this. I don't know if I'm going to get in trouble if my page or channel ever gets cut off because of a copyright infringement. I'll be back as soon as I get out of jail. Yeah, his is 85 right here. And that's above the 60. So I can see how he got suspicious. I'm not going to show much of this. I don't want to get, I don't even want to infringe on this gentleman. I haven't asked his permission yet. I need to start doing things like that. Again, that's if I buckle down and start doing professional videos instead of layman how I did it. In the video, he clicks on this EKF and brings up this status, and then he wiggles the quadcopter all around, seeing if it causes any problems. Now I'm going to do the same thing. I get a little compass, the green coming up in the compass. I'm not sure what that represents, but and a little position problems it looks like. But I'm just rocking. I'm just killing it with. And the same thing I was doing Saturday during the flight when those problems popped up in my log. I just set it down on the table. My God, what is this? Let me pick it back up off the table. Wow. I wonder what that is. Boy, fun with electronics, isn't it wild? Might be my keyboard, metal in my keyboard or something. Anyway, I figured I'd do that real quick before I did the compass motor, because he did. I'm ready to run the compass motor compensation utility. I am charging up a battery. I want it to be at full voltage for this test. I've also realized that I can do the first test the way the platform's been when it's been flying, and then I can take this rubber band and rubber band up the battery and do it again and see what it says in the difference in interference. So that's what we're going to do when the battery charges. Okay, got a cell phone camera on the platform, recording my screen, and I guess we should do this, huh? I'm going to have to arm it differently. I believe. Going to have to arm it here. I'm going to have to take just a little throttle, and then, no, let me go over there and try that utility first. It's been a while since I've done that. Optional hardware, compass motor calibration. I'm going to click start here and see if it bypasses everything. If it does, I'm going to quickly bring the throttle to 75%, count to 7, and drop it. Got no motors. Nope. So that's not going to work. So we're going to have to call that a finish. He got these same errors. So we will have to come out here. Arm. Take it slightly high so it won't stop. Come over here and click start. Woo! I did not like that worth a hoot, and I also didn't get any data. Boy, what did I do wrong? I don't think anything. I think I'm not getting the kind of current information that this utility needs out of that ESC. So, not sure what to do at this moment. I'm going to check all my work and then we'll see. Man, copter's connected. We heard the motors running. USB cable. Bet you dollars to donuts we did see current out here. We sure do. What the hell is that? Oh well. So, man. Oh well. That is unusual. His worked. We set our ESCs up the same. Our ESCs are the same. Okay. Back to the drawing board for a few minutes. Man. Okay. I did it again off screen. Off the video. Same thing. I just started over for scratch and went through it, and I'll try to do it again here on screen. That whole piece of wood moved around. Look at that. 366% interference. I think we're getting closer to our problem. How about you? So, this is how it ran. Now, I'm going to go ahead right now for kicks and grins. We're going to run out real quick and we're going to see what changed. Okay. Some of these down here may have changed. Yeah. CompassMOT. Okay. Yeah, here's the ones that changed right here. I'm going to save these away this way to a temp file. And I'm going to go out here. I'm going to shut everything back down, and I'm going to redo this with you guys watching for the second time. This time I'm going to use my rubber band. Don't like doing it again. I told you I would do this though. It's not fun. I hate this one, especially on this particular copter. I'll be right back. This is what I did off screen. I just followed these instructions and did exactly what it said. I disconnected the battery from the platform. I disconnected the USB from the platform. I disconnected it from Mission Planner. And I just started over and I went straight down through this.
Telemetry lost.
Okay, hush radio. And it worked this time. So I'm going to do it again. This is already done. This is already done. My copter's secured with more than tape. My transmitter's on. I'll connect the battery. This time I'm going to put the rubber band on it. And then I'll connect the autopilot with the USB, go into this utility, and click start. It goes through some things before anything gets going. So you'll see that this time. Okay, the battery's connected. I rubber banded it up this time. I got my throttle at 0. Connected the COM port. Connected Mission Planner. I hate this. Come straight into setup, going nowhere else, coming down to this perimeter. Click start. And now I saw this said disarming, but initializing autopilot. Okay, here we go. Whoa! I hate it. Look at that, 171%, half of it, by using the rubber band. And I think we've identified my problem with Saturday's flight, and we've certainly, hopefully, identified a problem where if I correct it, we're going to be in much better situation. I'm not going to go, well, I don't know whether I should go with the 171 or the other one that I did, but I'm going to quickly run out and save these different ones to temp 1. Whoops. Temp 1, enter. Okay. Whew. I'm going to get off the video real quick and get all this shut down. I don't like it. I actually did run it again for the final time with no cameras and stuff. I just didn't want to be distracted. And this was 147%, so that's above the 60. So we're in trouble still. We were in trouble before. This may compensate for it completely. So seeing, I went back and put my original parameters back in it and ran it one more time with the rubber band on it. So now I'm going to go and save to my master file. I like those. And now I can go in. Well, actually, we probably want to look at how those two compared. And well, I can show you how the first two compared because I took a snapshot before I blew everything back and did one last just for me without any video watching, so I would get it all right. Use the rubber band, and that's what I'm going to use. So just for kicks and grins, this is how those the two you saw, compared. This was the second one I did that was a lower, and this was the first one that was really high. So we're talking about these 5 parameters right here, I believe. This was the 300%, this was the 170. So these numbers aren't much different. This one is, in my humble opinion, drastically different at least 2 times. This one's like 7 times perhaps. This one's up a bit. This one's up a bit compared to these. But this was the 300%. I decided would be stupid not to be putting a rubber band on that battery pigtail now. I've been suspicious of this for weeks. I've mentioned it several times in the past. I made a big mistake not doing compass motor compensation as part of my build. I'm going to go back and at least correct the text in that video on my channel. Because I would have noticed this compass problem before I even did probably altitude hold test and got it a little more under control. Well, could have had a disaster Saturday. So there it is, ready to go again. I've got to change the props around, but now all the batteries that might possibly be used to fly it have a rubber band attached to them to do 2 things. Be ready to use when I attach that battery, and also to remind me that I have to do that. Well, I sure see now why he moved that compass, and I've been complaining about it almost from the start. So not sure what I will totally do about it, but this is a good starter using the rubber band. And also I think the compass motor compensation may take the interference out of it 100%. It worked well for me in the past. I'm just sorry I didn't make it part of the build. I will go back and amend the text, so maybe they'll know, and I'll put out another little addendum. But that's enough for this video. Somehow I keep getting them way too long. But I think this video was one of my most important. Thank you.